Hey, so I just wanted to go over our latest data that we just captured. Um, so this is actually the one where it didn't work out. This was our first attempt, and it got about halfway out there. Then I called it back home. That's why it's not straight. Um, but this is the one where it flew the full path. It did have a little bit of an issue landing, um, as you can see by this all that all those happenings going on right there. Not exactly sure what happened. I've had some issues with descent before. I've just been trying to tune it out. I think I may just be having an issue with my hardware itself. Pretty sure, actually. So on the first flight, for whatever reason, I didn't have any issues. There was, as far as the messages I got, everything's good. You know, just very few messages, just the basics. However, on this flight, and this is what happened last time, whenever there was an issue with the descent stability. The load monitor was telling me that my I2C1 was low on stack. And it just kept going and going and going. Unfortunately, because I had to rip the plug because it flipped over in the end, I only have pre-flight parameters, system states, and pre-flight counters. I don't have post-flight. So like on this one, you would see the pre-flight system state, post-flight system state, and then pre and post-flight performance counters. But I think I may have flown through something right here. If looking at the noise, I was flying. And that could have just been me turning around. I'll admit that, because there's also, yeah, actually, that's probably just me turning around because it's pretty symmetric right there. Yeah, I've looked through this data, and I'm not exactly sure. Nothing in here really makes sense. I believe it's just an issue with my flight controller. And it's version 1, and it came out, oh my goodness, I don't know. Well, this is the first revision of the hardware. So yeah, so it's 8 years old. There's much newer stuff out. In fact, stuff that's got like 4 or 5 times the running memory, and then stuff that's got 2 or 4 times as much programmable flash. And this hardware is actually not even being supported anymore. So it's just too old, and I have to upgrade in order to keep up with all the development that they've been doing on it. Because I've looked at a bunch of these logs, and I just updated the firmware, and I never ever would see these type of load monitor warnings. So if you'd like to see a fun, you'd like to see the Descent from Hell, you can watch it right here. And I don't know, I really can't explain it. I genuinely believe it's a hardware issue, and I've got a new flight controller coming tomorrow. It's the Pixhawk 4, not the Pixhawk 1, so we're jumping forwards quite a few generations here. And I think it's just the end of service of this hardware, and what was going off was my battery monitor, and I think that would just destroy the system load. And I mean, now you can see me, I'm just doing everything I can to get it back on the ground. Return to land, position, flight mode. It was just not having it. It was not having it. I mean, it was not having nothing. Eventually, I got it to the lowest mode that I was willing to go. So I didn't have any horizontal stabilization. All I had was a little bit of throttle modulation to help me with altitude. But I mean, once I took control of it, I mean, I could fly. It flew a lot better than when the computer was flying it. I think that was just the system glitching or something. I don't know. Or maybe it was the radar. Oh, yeah. Oh, I want to see that again. It lands. I'll have to make that bigger, make it giant. Oh, big drone, big drone. It flipped in the end, and that's what I broke my GPS stem. That's what we had to call it a day. But I'll get that fixed up. That's just a little wooden rod. That ain't nothing. As far as the Google Earth perspective, this was the first one where we didn't get data, and what it does is it climbs. It'll climb and it goes to this waypoint. This pin I dropped from our previous flights. So the last set of data we attempted to capture, that's where P1 came from. And so actually, I realized that yeah, I set okay, that makes sense. So yeah, I set that manually in Google Earth to 90 meters. And I noticed on our flights the other day that I was coming up a little bit low. Well, this time I came up a little bit high. So the altitude varies, probably different barometric pressures. But the main point of this is just to show other engineers how this works in terms of it climbs up, it goes to the first waypoint, and then it does the corridor, and it comes down. So you can actually take off from wherever you want to take off, because the first waypoint will always be your home position, and your last waypoint will always be your home position. As long as you set at least 2 waypoints to create the corridor, and it's pretty tight. If we get rid of that one that had returned to home, and I guess it's time to show you the lightning strike. Boom, right there it is. So as far as the horizontal alignment, you really can't ask for much more. It's really solid. And so we aimed the radar, or did our best to aim the radar at this P1. It was in between. I used to have a P2 that was out here, and it was kind of sort of in the center of that, angle-wise. But that just shows how repeatable it is. So even if we can't steer, if the searching thing is not going to work, we can still get real-world drone data because we can thread the needle. I mean, it's not easy, but we can definitely do that. So in terms of yeah, it looks like a lightning strike. That is what that's what I'm going to call it. But yeah, I just wanted to give give a visual so that people can see what they should be looking for, I guess.